All right, so here we're supposed to find all horizontal asymptotes f of x equals x squared over e to the minus x. Well, so that means what we're going to look at is we're going to look at the limits as x approaches negative infinity and the limit as x approaches positive infinity. All right, and so basically we're just going to find x squared over e to the minus x, and that's going to be x squared over e to the minus x. And where this actually gives us a value, that's going to be those horizontal asymptotes. All right, so let's go ahead and I guess work this one first. So if we plug in negative infinity here, that's going to be infinity. We plug in negative infinity here, that's going to be a positive, so it's going to be e to the positive infinity. And so as we go that way, that's going to give us an infinity as well. Okay. All right. Now let's go here and again, this one, if you have to think about that one, you have to kind of draw what e to the negative x looks like. And as you go to negative infinity, it goes up to positive infinity. All right, so now we just take derivatives. Limit as x approaches negative infinity. Well, that's going to give us what? 2x. And this one's going to give us what? Well, that's going to be e to the negative x times. Now the derivative of that's going to be a negative 1. Okay. Now if we plug in negative infinity here, that's going to give us what? A negative infinity. And here, e to the negative x, well, that's going to go to positive infinity, but we're taking the opposite of that, so it's going to be a negative infinity. Well, that gives us basically infinity over infinity. So we're still at this stage where we're stuck. So that means we take another derivative. All right, so now derivative of 2x is going to give us 2. Derivative of this, well, that's really just negative e to the negative x. So that's going to be a negative, and then it's going to be e to the negative x times a negative 1 again, because the derivative of this will give us, this again, because that goes from here, we went to here. So we're going to get that again. We still have the negative in front, so that becomes positive. So this is really 2 over e to the minus x. All right, well, e to the minus x as we go to negative infinity, well, it goes to positive infinity, so we get 2 over infinity. Well, 2 over infinity, well, that's going to be 0, okay? And so what happens is we're going to get y equals 0 is going to be one horizontal asymptote, and so that will be that. Now, what about here? What do we get? Well, here, if we plug in a positive infinity, well, that's going to give us infinity. Plug in a positive infinity here, that's going to give us what? Well, we're going to get 0 because it's going to go out this way and we're going to get 0. All right. And so thinking about this, well, since we're going to positive infinity, maybe let's rewrite this as the limit as x approaches infinity of x squared e to the x. Well, what's that equal to? Well, if we plug infinity in here, we get infinity, and then e to the x. Now remember, this one is going the opposite direction, and so that's going to be times infinity, and so that's infinity. And so because of that, there's going to be no horizontal asymptotes based on this one. So the only one we get then is this. Okay, so that's kind of a key piece to think about here. And as we did all of this, also if we plugged in our positive infinity all the way down here, then what we would get was be as we go to positive infinity, we get 0. So we're going to take 2 divided by 0, which is undefined. And so that's another way to look at it. But here's, we just did it this way. And the other way, again, is if we would have said, okay, well, a limit as x approaches infinity of 2 over e to the minus x, that's going to give us 2 over 0, and that's undefined. And so that way, it gives us no horizontal asymptotes in that manner too. So it kind of depends on how you want to look at that one, but that will give you the solution both ways. All right. So theorems 1 and 2 on L'Hopital's rule cover a multitude of limits, far too many to remember by case. So instead, we suggest you use the following pattern. It's common to both theorems as a memory aid. So all cases involve 3 limits: the limit of f of x over g of x, the limit of f of x, and our limit of g of x. Okay, so the independent variable x must behave the same way in all 3 limits. So the accepted behaviors are as it approaches c, C from the right, C from the left, infinity, or negative infinity. And the form for the f of x over g of x has to be 0 over 0 or plus or minus infinity over plus or minus infinity. And both the limit of f of x and g of x have to approach 0 or they both have to approach plus or minus infinity. Because remember, we have to have one of those to work. And once we have these, then we can take and use L'Hopital's rule, take the derivative, and then we're going to find the limit of the derivative of f of x over the derivative of g of x. And then hopefully we get a number. If not, if we get one of these again, then we take another derivative. If we don't, and we get something like, x minus 1 squared, and we're taking the limit as x approaches 1, then we have to look at the graph. So we can either do derivatives until we get to an answer, or we take derivatives until we can actually use a graph form and then get our solution that way. So either way, we have to get our way down to the point where we can solve and get that actual limit. All right, so hopefully that will help you with this section.